Hello again. This is question 30 from the 2013 exam. It comes in two parts. Firstly, you have to explain why tan of pi on 2 plus x equals negative 1 over the tan of x. And secondly, you have to use this result to show something else. So, the first part, we must explain why this equals this. Tan of pi on 2 plus x is a situation of vertical symmetry. I can tell that because I have pi on 2 here. Some of you might be used to using the idea of complementary angles. I will deal with this in the way I usually do it, which is to talk about vertical symmetry as opposed to horizontal symmetry. The rules for vertical symmetry are that sines change into cosines, cosines change into sines, and tans change into 1 over tans. So for this situation we have here the tan of pi on 2 plus x, that will be the same as 1 over the tan of x. There is still to decide whether we are going to be plus or minus that. That plus or minus decision comes from the cast diagram. We must mark in where we are. Now the angle pi on 2 is the vertical line there, and plus x will put us into this quadrant here. That's x, and in this quadrant only signs are positive, everything else is negative, so I know that I will have negative 1 over the tan of x. So my thinking here is I've used the rules of vertical symmetry, change the tans will change into 1 over tans, and then the plus or minus comes from the cast diagram, so that's why that equals that. And explaining why that's true, well, my explanation is I've used vertical symmetry and the cast diagram. Second part, do this in a different colour. Use this result to solve this equation in this domain. Okay, so if I have to solve tan pi on 2 plus x equals root 3. Well, I don't need to use this result to solve this, but the question tells me to use this result, so I will do what I'm told. And we will say that means, therefore, because this is equal to negative 1 over tan of x, that also equals root 3. This is what I'm going to solve. I will invert both sides of this equation and get negative tan x over 1 equals 1 over root 3, and multiply both sides by negative 1. Tan x equals negative 1 over root 3, and this is perfectly correct, but I will change this so it's got a rational denominator by multiplying by root 3 over root 3, which equals negative root 3 on 3. Right, that's what I'm going to solve. First thing I will do is find the basic angle. That is tan of something equals root 3 on 3. Triangle 2, 1, root 3, and that is pi on 6, the angle in the corner there, because the tan of pi on 6 equals root 3 and 3, well, 1 on root 3 or root 3 on root 3 on 3. So the basic angle is pi on 6. Draw my cast diagram. equation that I'm solving is this one. Tans are negative. So for tans to be negative, I must be in either this quadrant or this quadrant, where the angle to the horizontal is my basic angle, pi on 6. And I'm looking for my solutions in the domain 0 to 2 pi. So x equals, from 0 starting to 0 on the way around to 2 pi. The first solution I bump into is that one, which is pi minus pi on 6, and the second solution that I meet is that one, which is 2 pi minus pi on 6. Or in other words, my solutions are 5 pi on 6 and 11 pi on 6. And that is it.